In this problem, question 6, we're given an average cost function and it's of a solar panel producer, and the function is given by f of x equals 0.001x squared minus 0.8x plus 500 plus 50,000 over x. X is the number of solar panels, and what you're asked to do is verify that the derivative, so we'll calculate the derivative in just a second, but when we evaluate the derivative at x equal to 500, we've got to confirm that it equals 0, and subsequently that that's a minimum of the function. Now, this function looks, to start off with, just like a regular old quadratic. There's an x squared, but it's got an extra term sitting in here, makes it a bit more interesting, and that's 50,000 over x. And so we'll see what our derivative looks like in this case. So I've now written down the average cost function, and we're going to find its derivative, in other words, a primed of x. And when I do that, I'll start with the 0.001, that's a multiplicative constant. Derivative of x squared is 2 times x. Derivative of negative 0.8x is 0.8. Derivative of the additive constant 500 is 0, and then I need to differentiate 50,000 over x. Now, 1 over x is the same as x to the power minus 1, and then we'll use the rule bring down the power, knock the power down 1. So that's going to give me minus, and then I'll have 50,000 over x squared, because x to the minus 1, knock the power down 1 is x to the minus 2, and that's the same as over x squared. So that's the derivative. Now, you were asked to find the derivative evaluated at 500. So I'm just going to put in 500 now. So that's 0.001. 2 times 500 is 1,000. Minus 0.8, well, that doesn't depend on x. And then minus. If we have a look what we have here, we have 50,000 on the top. And we're going to have 500 squared at the bottom. So we do 5 squared, we'll get 25. And then we've got the 100 to be squared. So there's 100, and there's another 100 coming in on the bottom. So that's our expression. Now we can simplify. 0.001 times 1,000 is just 1. Negative 0.8, well, we'll just leave that alone. And negative 50,000 over 250,000 is simply negative a fifth, or negative 0.2. And if I do 1 minus 0.8 minus 0.2, I do indeed end up with 0. So that was what we were asked to do at the beginning of the question, to show that the derivative evaluated at 500 was equal to 0. So the next thing we have to do is confirm that this is indeed a minimum. So this is our question. Is it a minimum? Well, we check that by looking at the second derivative. And so a double primed of x, let's see what the second derivative is equal to. And of course we'll evaluate that at the 500. So a double primed of x equals. So in order to do that, I'm going back to what a primed was, and I'm going to differentiate again. And I have the 0.001 times 2x. So that is, when I differentiate the 2x, I just get 2. So that will be 0.001 times 2, which is 0.002. Now the negative 0.8 is an additive constant, so that's going to disappear. And I will then have the 50,000 over x squared, but it's minus 50,000 over x squared. So just put in the minus, and then 50,000 over x squared, that's the same as 50,000 times x to the minus 2. So we're going to bring down the power. There's the minus 2. Knock the power down 1. I'll write it as x to the minus 3. And that's the value. Now if we have a look at this expression, it's 0.002. But we see we've got two minuses, a minus there and a minus there, so we can put in a plus. And I can do 2 times 50,000 is 100,000. And that's over x cubed. And what we want to have a look at is a double primed at x equal to 500. And rather than working it out, I'm just going to make a couple of observations here. The first one is that 0.002 is indeed a positive number. And then I'm adding something positive, and this is, so adding is positive, and then 100,000 over x cubed, where x is positive, is indeed positive. So I'm adding on to that another positive number. And so the whole thing is positive. And if the second derivative is positive, then we know we are indeed looking at a min. So we have established that this is a minimum.